I am Professor M.V. Malkanavar, Department of Physics, Government First Grade, Women's College, Jamkandi. Today, we have to see the BSc 5th SEM, BSc 5th SEM, paper 5.1, first chapter, Properties of Atom, the last session, that is problems. We have to discuss problems one by one. See here. The first problem. An electron starts from rest and moves freely in an electric field of intensity 2400 volt per meter. Determine force and acceleration of an electron. See the given quantities. Electric field intensity E 2400 volt per meter. Charge on the electron we know 1.6 into 10 to the power minus 19 coulomb. Now, the force acting on the electron due to electric field F equal to small e into capital E. Substituting small e and capital E values, we get the force acting on the electron as 3.840 into 10 to the power minus 16 Newton. Now, we have to calculate the acceleration. We know F equal to ma, therefore acceleration equal to F by m. F 3.840 into 10 to the power minus 16 Newton and mass of the electron 9.1 into 10 to the power minus 31 kg. After simplification, we get 4.21 into 10 to the power 14 meter per second square. The problem is very simple. Now we go to the second problem. See the second problem. A charged oil drop is suspended in a uniform electric field of 300 volts per centimeter so that it neither falls nor rises. Find the charge on the drop given its mass is 9.75 into 10 to the power minus 12 gram. See the given quantities. Strength of the electric field is given, that is 300 volts per centimeter. After converting in SI system, we get 300 into 10 to the power 2 volts per meter. Now, the mass of the charged oil drop 9.75 into 10 to the power minus 12 gram. After converting in SI system, we get 9.75 into 10 to the power minus 15 kg. They ask the charge on the oil drop. They told that charged oil drop is neither falls nor rises in an electric field. Therefore, a gravitational force acting on the drop is equal to the force due to electric field. That is, gravitational force mg equal to force due to electric field q into E. Therefore, q equal to mg by E. Substituting the value of m, g and E, we get the charge on the oil drop as 31.85 into 10 to the power minus 19 coulomb. Now we go through the third problem. Electrons move at right angles to the magnetic field 2 into 10 to the power minus 2 Weber per meter square, and it enters the field with the velocity of 10 to the power 7 meter per second. Find the radius of the circular path. See the given quantities. The strength of the magnetic field is given B equal to 2 into 10 to the power minus 2 Weber per meter square, and the velocity with which the electrons are moving, that is 10 to the power 7 meter per second. Electrons entering the magnetic field at right angles to the magnetic field. Therefore, electrons move in a circular path. Necessary centripetal force is provided by force due to magnetic field. That is mv square by r equal to BeV into sin theta, but theta equals to 90 degree. Therefore, after dropping V from both sides, we get the radius of the orbit as mv by Be. M, mass of the electron 9.1 into 10 to the power minus 31. V, velocity of the electron 10 to the power 7. Strength of the magnetic field. The strength of the magnetic field 2 into 10 to the power minus 2, and charge on the electron 1.6 into 10 to the power minus 19. we get 2.843 into 10 to the power minus 3 meter, that is 2.843 millimeter. That is not 3 into 10 to the power minus 2, that is 2 into 10 to the power minus 2. Finally, we get 2.843 millimeter, that is the radius of the circular path in the magnetic field. Now we go to the fourth problem. A water drop is charged by an electron and is placed in an electric field. What is the intensity of electric field required to keep the drop stationary? Given radius of the drop equal to 10 to the power minus 4 millimeter. See the solution. Radius of the drop small r equals to 10 to the power minus 4 millimeter. 10 to the power minus 4, 1 millimeter means 10 to the power minus 3 meter. Finally, we get the radius of the drop 10 to the power minus 7 meter. Now, we have to write the density. We know the density of water 1 gram per cc in CGS system. If we convert the CGS system into SI system, then the density of water is 10 to the power 3 kg per meter cube. Therefore, density equals to mass divided by volume. Therefore, mass equals to density into volume. Density rho, the radius of the drop is given. Assume that radius of the drop is r, then the volume of the drop is 4 by 3 phi mr cube. 4 by 3 mr cube. 4 by 3 phi r cube. 4 by 3 phi r cube. Substitute the value of phi 3.142, substitute the value of r and substitute the value of rho. We get the mass of the drop 4.189 into 10 to the power minus 18 kg. Water drop remains stationary. They told water drop remains stationary. Therefore, force due to electric field is balanced by gravitational force. That is small e into capital E equal to m into g. Therefore, capital E equal to m into g divided by small e. After substituting the values of m, g and e, we get the strength of the electric field as 256.57 Newton per coulomb or volt per meter. Now we go to the fifth problem. A charged oil drop is just floating in uniform electric field of 300 into 10 to the power 2 volt per meter. Find the charge on it. Given mass of the drop is 9.75 into 10 to the power minus 15 kg. Mass of the drop 9.75 into 10 to the power minus 15 kg ಕೊಟ್ಟಿದ್ದಾರೆ given, and the strength of the electric field is given, that is 300 into 10 to the power 2 volt per meter, that is 3 into 10 to the power 4 volt per meter. Then they told that charged oil drop is just floating in a uniform electric field. Therefore, force due to electric field is balanced by gravitational force. Therefore, Q into E equal to M into G, Q equal to M into G divided by E. After substituting the value of M, G and E, we get the charge on the drop as 31.85 into 10 to the power minus 19 coulomb. Now see the last problem. A mono-energetic electron beam moving with a speed of 5.20 into 10 to the power 6 meter per second is subjected to a magnetic field of 1.30 into 10 to the power minus 4 Tesla, normal to the beam velocity. What is the radius of the circular path traced by the beam? Given that E by m for the electron is 1.75 into 10 to the power 11 coulomb per kg. See the given quantities. Velocity of electron beam, that is 5.20 into 10 to the power 6 meter per second. Strength of the magnetic field B equal to 1.30 into 10 to the power minus 4 Tesla. Theta equals to 90 degree. The beam is entering normal to the magnetic field. The E by m of electron is given that is 1.6 into 10 to the power 19 coulomb per kg. The radius of the circular path in the magnetic field is given by R equal to mv by Be. R equal to, write V as it is, transfer m to denominator, that is B into E by m. Therefore, R equal to, after substituting the value of V, after substituting the value of capital B and E by m, we get the radius of the circular path as 2.27 into 10 to the power minus 1 meter, that is 0.227 meter. Thank you to one and all.